Hi everyone, for today's lesson we are going to learn about how to add, subtract, and multiply polynomials. Before we get started, I would like you to please go ahead and complete this really quick warm-up where I would like you to please simplify each expression. Use your properties of exponents, use what you know about combining like terms in order for you to answer each question. And when you're finished, go ahead and restart the video and we'll see how well you did. All right, let's go ahead and check your answers. The first thing you want to do is multiply -3 times 5. You'll end up with -15. Then when you multiply x to the third times x, you simply add your exponents. That'll make that -15x to the fourth. For number 2, we are combining -9x minus 18x. They are like terms, so this is going to become -9x. We would not add any exponents. We would just simply combine our like terms. For number 3, we have 10y squared plus 7y minus 8y squared minus 1. So I'm going to combine all of my y squareds together, and I end up with 2y squared. And then 7y doesn't have a like term, so that's going to be plus 7y, and then minus 1. The way that it is written is considered standard form, and that's because our exponents are written in descending order. And from here on out, all of your answers need to be written in standard form. For number 4, I'm going to use the distributive property, and I have -20a plus 24, and then we have minus 2a and plus 16. Now, just like before, I'm going to combine my like terms. -20a minus 2a is -22a, and 24 plus 16 is 40. So your answer is -22a plus 40. So now, just like the lesson, or the title of the lesson says, today we are going to learn about how to add, subtract, multiply, and multiply polynomial expressions. So by the end of the lesson, I want you to be able to say, I can add, subtract, and multiply polynomial expressions. Also, I want you to be able to say, I can use special product patterns. This special product pattern is going to be called LEAL. I call it the LEAL. And LEAL, believe it or not, comes from a thing from SpongeBob that my last year students ended up coming up with, which is kind of a really cute and weird thing all at the same exact time. And like I said, I'll talk about that a little bit later in the lesson. So this can be used to multiply certain polynomial expressions. So let's go ahead and look at example number 1. For example number 1, we can add polynomials vertically, and we can also add polynomials horizontally. So to add polynomials vertically, you'll add the like terms or line up your like terms together. If there exists a term that doesn't have a match, you can leave it blank or insert a 0x or a 0x squared for whatever term is missing, for whatever degree is missing. And then you simply add going straight down. So we have 3x cubed plus 1x cubed, that's 4x cubed. -2x squared minus 5x squared, that's minus 7x squared. 4x plus 0x, that's plus 4x. And -6 plus 3 is minus 3. That is it. That is your entire answer. Let's go ahead and look at letter B. For letter B, you can add going horizontally, where if you have two polynomials and you see an addition side, please, please, please do not FOIL. This is not a FOIL situation. On one of our last tests, or a couple tests ago, people wanted to FOIL, but we're actually adding these values, which means that we're going to drop the parentheses and then simply combine your like terms. CLT means combine your like terms. So I'm going to rewrite this as 2y cubed plus 7y squared minus 6y minus 4y squared plus 3y minus 9. Combining my like terms, I have 2y cubed, and that's my only 2y cubed, so that's going to be first. Then I have 7y squared minus 4y squared, so that's plus 3y squared. Then we have minus 6y plus 3y, which is minus 3y, and then we have minus 9. So that is combining all of our like terms. You can also subtract polynomials vertically as well as horizontally. So if we were to subtract vertically, you would simply write down what you're subtracting on the outside of a set of parentheses. And then you can see kind of this arrow right here. So what we're going to do is we're going to distribute the negative to every single term in the parentheses. And then we're going to add going straight down. So negative 6x cubed, the negative times positive is minus 3x squared. Negative times negative is a positive 7x. And negative times positive 5 is minus 5. So all I did here was distribute the negative to each term, and now I'm going to combine my like terms by adding going straight down. So 7 minus 6, that's x cubed, and then negative 6x squared minus 3x squared, that's minus 9x squared. Negative 3 plus 7x, that is plus 4x, and 7 minus 5 is 2. And that is simply your answer. So you can add vertically, or you can subtract vertically, or you can subtract horizontally. This is something that we have done before with other expressions. Once again, if you see two parentheses with a minus sign, please distribute that minus sign to every single term inside. Once again, do not FOIL. We are not multiplying our two parentheses in this case. Just simply distribute the negative to each term and then drop your parentheses and combine like terms. So that's combine like terms. So I have 8t plus 6 minus 5t squared minus 2t to the third power plus 3t squared minus 7. So now I'm going to rewrite this in standard form, working with my largest exponent first. And in this case, negative 2t to the third power is my largest exponent. So I'm going to write negative 2t cubed first, and then I'm going to combine my square terms. Negative 5 plus 3, that is minus 2t squared. Then I'm going to combine, there's no other 8t, so there's nothing for me to combine. So that's plus 8t. And then we have 6 minus 7, which is minus 1. And that is your answer. So now we've added polynomials, we've subtracted polynomials, now it's time to multiply. So whenever you multiply polynomials, you can use a box or you can do a massive FOIL. So that is two different approaches. You can either use a box or you can do a massive FOIL. So for the first one, I'm going to show you the box method. We have a binomial times a trinomial, which means that we need to have a 2 by 3 grid. So my two terms are going to go on the side, that's an x and a 2. And my three terms are going to go at the top. That's 3x squared minus x and then a positive 4. So the only signs that need to stay attached are the negative signs or the minus signs. The other terms can just remain positive. And now, just like you would a Punnett square, you would multiply your factors in. So I'm going to multiply 3x squared times x to get 3x cubed. 3x squared times 2 is 6x squared. Negative x times x is minus x squared. Negative x times 2 is minus 2x. 4 times x is times 4 is 4x. And 4 times 2 is 8. What you want to do now is combine your like terms. Typically your like terms are going to be along the diagonals. So my answer is going to be 3x cubed. 6 minus 1, that's 5, so plus 5x squared. Negative 2 plus 4 is plus 2x, and then plus 8. And that is your answer. The other approach is to do what I call a massive FOIL. So what I'm going to do is I'm going to eliminate the box, and I'm going to show you what the massive FOIL looks like. The massive FOIL is where you multiply every single term in the first parentheses times every single term in the second parentheses. And then I'm going to line it up vertically and combine my like terms. So I'm going to multiply x times 6x squared, and I end up with 6x cubed. Then I have x times 3x, which is plus 3x squared. Then x times minus 5, which is minus 5x. Now I'm going to multiply negative 2 times every single term in the second parentheses, and I'm going to line up my like terms vertically. So negative 2 times 6x squared is minus 12x squared. Then negative 2 times 3x is minus 6x. And then negative 2 times negative 5 is plus 10. From here, I'm going to add going straight down, and I'm going to put in a 0x cubed and a plus 0 at the top for lining up my like terms. Anytime you have a degree that is missing, you would simply put in a 0. Now, do you have to? No. Do you even have to add vertically? No. You can add horizontally. I just wanted to show you another approach. So we have 6x cubed plus 0x cubed. That's 6x cubed. 3x squared minus 12x squared is minus 9x squared. Negative 5x minus 6x is minus 11x. And 0 plus 10 is 10. And that is your answer. So whenever you receive these problems, you might ask, what approach am I looking for? Well, the answer is, I don't care. For a lot of these problems, I don't care how you get the right answer. The point is, can you get the right answer and show me a little bit of work along the way? So now what we're going to do is we're going to multiply 3 binomials together. So in order for you to multiply 3 binomials together, the first thing you need to do is you need to use FOIL, or the distributive property, to multiply 2 out of the 3 binomials. Then, once you have a product, which is going to be a quadratic, then you'll multiply the polynomials. So if we want to multiply x minus 3 times x plus 7 times x plus 1, the first thing I'm going to do is multiply your x minus 3 times x plus 7, and I'm going to come up with an answer. So I'm going to multiply by using the distributive property, or using FOIL. X times x is x squared. X times 7 is plus 7x. Negative 3 times x is minus 3x. And negative 3 times 7 is minus 21. Combining my like terms in the center, I have x squared plus 4x minus 21. So the product that we ended up coming up with from the first parenthesis is x squared plus 4x minus 21. And so that is step 1. Now that I have my first product, the next thing I'm going to do is I'm going to multiply this result by my remaining parenthesis. So I'm going to multiply x plus 1 times x squared plus 4x minus 21. You can use a box, or you can use the massive FOIL. So if we were to use a box, I would have x and 1 be along the side, because we've just created a 2 by 3 grid. And then I would have x squared and 4x and a negative 21 on the top. So now I'm going to multiply in, and I have x squared times x, which is x cubed, x squared times 1, which is x squared, 4x times x, which is 4x squared, 4x times 1 is 4x, negative 21 times x is minus 21x, and negative 21 times 1 is negative 21. Along the diagonals are your like terms, and that's what we're going to combine. So my answer is x cubed plus 5x squared minus 17x minus 21. So that is one approach. You could FOIL using the first 2 terms, and then come up with a product and then multiply it by the last 2 terms. So what I'm going to show you now is the massive FOIL. I'm not going to use the box. So the first thing I'm going to do is multiply the first 2 parentheses together, and I'm going to come up with an answer. So I'm going to have x squared minus 6x plus 3x minus 18, and I'm going to combine my like terms, and I end up with x squared minus 3x minus 18. So that's my product. That's my first product, x squared minus 3x minus 18. And now what I'm going to do is I'm going to now multiply it by my remaining parenthesis, which is x plus 5. And I'm going to show you a massive FOIL. So now I'm going to have x squared minus 3x minus 18, and I'm going to multiply it by x plus 5. So every single term in the first parenthesis will get multiplied by every single term in the second parenthesis. So I have x squared times x, which is x cubed. X squared times 5x squared is plus 5x squared. Negative 3x times x is minus 3x squared. Negative 3x times 5 is minus 15x. Negative 18 times x is minus 18x. And negative 18 times 5 is minus 90. Combining my like terms, we end up with our answer being x cubed plus 2x squared minus 33x minus 90. So I showed you how you can add or subtract going vertically, horizontally, as well as how to multiply binomials. You can use a box or you can use a massive FOIL method. Any method that you use is perfectly fine. Just show me how you got your answer. So now we're going to learn about special products. Some of the special products we've already learned about, like difference of two squares. We call that dots, difference of two squares. And what that looks like is if you have two parentheses that have exactly the same information inside, but the only difference is one has a plus and one has a minus, that product is going to be a difference of two squares. So if you have a plus b times a minus b, so they have the exact same information inside, the only difference is one parenthesis has a plus and the other one has a minus. When you FOIL it out, your final answer is going to be a difference of two perfect squares, a squared minus b squared. You also have a square of a binomial, which we call that a perfect square trinomial, a PST. There are two of those. If you see a plus b squared, your answer is automatically going to be a squared plus 2ab plus b squared. The other one is a minus b squared. So that's going to be equal to a squared minus 2ab plus b squared. So its product is the only thing that's different between the two products is one has a plus sign and one has a minus sign. I strongly recommend that you use these shortcuts whenever available. It makes your life so much easier and it saves you a lot of time. However, if you are a person who's just not there yet when it comes to using special products, you're more than welcome to FOIL it out to come up with your answer. But like I said, I strongly recommend that you identify your patterns because it will save you a tremendous amount of time. Now we have ourselves a new product. This is a product rule that you must know for your test. So this is something that you must know. This is called a cube of a binomial. I call it the 1-3-3-1 rule, which also looks like the word leal, according to my my students from last year, which apparently there was a guy named Patrick on SpongeBob who apparently said leal, 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 leal the whole time. And so for some reason, that was the way that everyone remembered this product rule. It is your leal rule, 1-3-3-1. And so if you were taking a binomial and cubing it, the product is going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. So the way to remember it is that your numbers in front are going to be 1, 3, 3, 1. Then your exponents are going to go 3. I guess I'll write this right here. Your exponents are going to be 3, 2, 1, 0, then 0, 1, 2, 3. So those are with your exponents. Look at your exponents. With respect to the first term, it goes 3, 2, 1, 0. And with respect to the second term, 0, 1, 2, 3. That is the pattern. We'll explore this a little bit more, but that is the pattern for both of these. The only difference is that whenever you have a minus sign and you're cubing a binomial with a minus sign, that means that you're still going to have 1, 3, 3, 1, and your exponents are still going to be 3, 2, 1, 0, 0, 1, 2, 3. So I'm going to write that down. So that's going to be the same. 3, 2, 1, 0, 0, 1, 2, 3. But what's different is that we alternate the signs. So it goes a positive, which we don't really write the plus sign, but positive, negative, positive, negative. We alternate the signs. Positive, negative, positive, negative. Let's go ahead and do a few of these examples so that the pattern actually makes a little bit more sense for you. Let's look at letter A. For letter A, we have 7m minus 3 times 7m plus 3. This is considered a difference of two squares situation, and that's because each parenthesis has the exact same information in it. The only difference is that one parenthesis has a minus and the other parenthesis has a plus. So the way that we're going to factor this is we're going to take our first term, which is 7m, and we're going to square it, minus my last term, which is 3, and we're going to square it. So my answer is 49m squared minus 9. You're more than welcome to FOIL it out, but you'll end up with the same exact answer. You take your first term, you square it, you take your last term, you square it, and you put a minus sign in the middle. Let's look at letter B. Letter B, we have 4t to the third power plus 6 squared. So this is a perfect square trinomial. So what we're going to do is we're going to take our first term, which is 4t cubed, and we're going to square it. Then we're going to write, because it's a plus sign, plus 2 times 4t squared times 6. Then plus my last term, which is 6 squared. Now I'm going to simplify each expression exactly as I see it. So to square something is to multiply it by itself twice. And what I'm going to do is I'm going to square 4, that's going to make it 16, and 3 times 2 is 6. So that's 16t to the 6th power. Plus, I'm going to multiply all of my numbers together. 2 times 4 is 8, and 8 times 6 is 48. That's going to be 48t squared. Then plus 6 squared is 36. So could you bring it up or tear it apart into two parentheses and FOIL to come up with this answer? Absolutely. But technically, that's more work. And the goal here is to try to use our patterns to try to save us some time and save us some work. Let's go ahead and look at letter C. Letter C is considered a Lille situation. It's a cube of a binomial. So I call these the Lille situation. So the way I'm going to break it apart is this. I'm going to write very, very deliberately the number 1. I'm going to leave a couple fingers of space. Then I'm going to write the number 3, leave a little bit of space, and then a 3, and then leave a little bit of space, and I'm going to write a 1. Since we have a minus sign, I'm going to be, I'm not going to worry about my minus signs yet, but I do know that I'll be alternating my signs. So don't worry about the signs until the last thing. So I'm going to alternate the signs. And it's always plus, minus, plus, minus. Positive, negative, positive, negative. Now what goes into my first term, or my first position, is my first term, xy, and I'm going to raise it to the third power. Then I'm going to take my first term, which is xy, and I'm going to raise it to the second power. Then I'm going to take my first term, which is xy, and I'm going to raise it to the first power. Then I'm going to multiply take xy and raise it to the 0 power. Now I'm going to do the reverse. So when I said with respect to your exponents, it goes 3, 2, 1, 0. Then we go 0, 1, 2, 3. And this is respect to the first term and the second term. So we have our first term and our second term. My second term is 4. So this is going to be 4 to the 0 times 4 to the first times 4 to the second and then times 4 to the third. Now I'm going to insert my signs. So my signs are positive, negative, positive, negative. So my first term is positive. If you want to remind yourself that that's a positive by putting a little plus sign in front, that's fine. Then I have minus, then I have plus, then I have minus. So I've just alternated my signs. Now I'm going to simplify each expression individually to come up with an answer. Be careful with your properties of exponents. That's where kids make their biggest mistakes. The first thing I'm going to do is work with the numbers. I have 1 and 4 to the 0. Well, 4 to the 0 is just 1, and 1 times 1 is 1. So I'm not going to really write a number. If you want to write the number 1, that's fine too. Now I have x times y to the third power, so that's going to be x cubed, y cubed. And that's the result of my first term. Minus, I'm going to work with my numbers. 3 times 4 to the first, that's 12. 3 times 4 is 12. Now I'm going to distribute that square to each term, and that's going to be x squared, y squared. Now I have plus 3 times 4 squared. Well, according to the order of operations, you have to take care of your exponents first. 4 squared is 16, and 16 times 3 is 48, so that's plus 48. And then we have x times y raised to the first power, so that's simply xy. Minus, taking care of my numbers, I have 1 times 4 to the third. 4 to the third power is 64. So I'm going to write down the number 64. And any quantity to the 0 power is just 1. So like that term would cancel away. And this is your answer. X cubed, y cubed, minus 12x squared, y squared, plus 48 xy minus 64. Let's go ahead and do that again. So I have 3x plus 2y cubed. So what I'm going to do is I'm going to write down my 1, 3, 3, 1, leaving a little bit of space in between my numbers. I'm going to take my first term, which is 3x, and I'm going to put it into parentheses and raise it to the third power. Then I'm going to raise it to the second power. Then I'm going to raise it to the first power. And then I'm going to raise it to the 0 power. Then I'm going to take my second term, which is 2y, and I'm going to write 2y to the 0 power, 2y to the first power, 2y to the second power, and then 2y to the third power. Since I have a plus sign in the middle, all of my signs are plus. So I'm going to put a plus sign in front of all of my numbers. Now I'm going to take care of each expression individually, working with my numbers first. So this is simply 1, and now I have 3 to the third power. 3 to the third power is 27. 2 to the 0 power is just the number 1. So 3 to the third power is going to be 27, and that's my leading coefficient. I now have x to the third power, and this whole quantity of 2y is being raised to the 0 power. Now I'm going to write plus. Working with my exponents first, I have 3 squared. 3 squared is 9. 9 times 3 is 27, and 27 times 2 to the first is 54. So once again, what I did is I took care of my exponents. 3 squared is 9. 9 times 3 is 27. 27 times 2 is 54. Now my exponents are going to be x squared, and this is a y to the first power. Plus, working with my exponents, I have 2 squared, that's 4. 4 times 3 to the first is 12. 12 times 3 is 36. So once again, I took care of my numbers using the exponents first. 2 squared is 4. 4 times 3 to the first, which is 4 times 3, is 12. 12 times 3 is 36. So now I have x and then y squared. Now working with my numbers and my exponents, 2 to the third power is 8. And then anything to the 0 power is 1, so it's like this term kind of goes away. And 8 times 1 is 8, so plus 8, and that's going to be 8y cubed. And there's your answer. And finally, for letter D, this is once again a perfect square trinomial. So what that means that we're going to do is I'm going to write down my first term, which is 6q, and I'm going to square it. Then because there's a minus sign in the middle, means that my next sign is minus. In a way, we're alternating our signs as well, just like with our Lille situation. So now I'm going to have 2 times 6q times 3r. And then our last term, which is 3r, I'm going to write plus 3r, that whole quantity squared. Notice I've used a lot of parentheses in this lesson, and that's because the parentheses have meaning. You have to be very, very careful that you square all your numbers as well as your letters. So now I'm going to have 6 squared, which is 36, q squared. Then minus 2 times 6, which is 12. 12 times 3, which is 36. 36qr. Your letters should be in alphabetical order. And finally, 3 squared is 9, and we have 9r squared as our final answer. Because this is a lot of information and the story problem is not something that we're going to be focusing on, I'm going to be skipping the story problem for this lesson, and I also want you to skip the story problem in your homework as well. So that is the end of this lesson. If you have any questions over anything, please feel free to email me. We're going to be practicing these skills a lot on Monday and Tuesday, or the next time that I see you. And like I said, if you have any questions over anything, please make sure that you let me know. Otherwise, I'll talk to you soon.